Here we have the coordinate transformation worksheet. Section A asks us to transform each given geometric figure on the coordinate plane as described. Then we want to describe the transformation using coordinate notation. So let's start with question 1. Question 1 says to translate trapezoid ABCD 11 units to the right. Translate is another word for slide. So if I slide A 11 units to the right, it should end up right here, right? You just count out 11 units. Same thing for D. If I slid it 11 units to the right, it ended up there. And for C, and then finally for B. And the final shape should look like this. Now if you notice, if we call these the original coordinates x, y, then the y coordinate for those coordinates remained the same, but the x coordinate increased. And so if we wanted to describe this transformation with coordinate notation, we would say that all of our x values increased by 11 units, and our y values remained the same, right? Number 2 asks us to translate triangle EFG 8 units up. So translate is another word for slide. We're just sliding 8 units up. So E goes from being here to being 1, 2, 3, 4, 5, 6, 7, 8 units right there. F will end up right there, and G should end up here. And so if we connect those to make our shape, it's going to look like this. So if you notice, on this one, our x, if we think of our coordinates for E, F, and G, the x values of those coordinates remain the same when translating up, but the y coordinates changed. And so if we want to write the coordinate notation to describe this transformation, we could say that the x, y coordinates were transformed to become such that x remained the same, but y increased by 8 units because we translated 8 units up. And so generally, and you can see this on your coordinate transformation reference sheet, if we're translating either to the left or right, our x coordinates are going to change by some amount c. And if we're translating up or down, our y coordinates are going to change by some amount c. And that's exactly what happened here. Now moving on to question 3, this one asks us to rotate rectangle HJKL 90 degrees counterclockwise about the origin. So we're going 90 degrees counterclockwise, and we're going about the origin as our center of rotation. So one way of doing this is by using something called the hook method. Now the hook method is basically, let's say we want to rotate point L 90 degrees counterclockwise. We can draw something that looks like this to point L. And now this structure is a lot more easy to visualize how it would look if it was rotated 90 degrees this way, right? This horizontal part would now be vertical, and so it would look something like this. And this vertical part would now be horizontal and on this side, and so it would look something like this, 4 units. Right, so this is 3 units this way, and so now it was 3 units up, and this was 4 units this way, and so when it rotated 90 degrees, it became 4 units in this direction. And so we can use that to find our new point, L prime. And you can do that hook method for all the points, and you would be able to draw your figure over here. But another way of doing this is by using the coordinate notation for transformations. Right, so if we go back to our coordinate transformation sheet, you can see here that in the section labeled rotations, if we are going 90 degrees counterclockwise about the origin, our original x, y points are going to be transformed such that the two coordinates flip sides and the new x coordinate becomes negative. Right, so let's go ahead and write this information over here so we can see it more readily. X, y are going to become negative yx. And so let's go ahead and use this to transform points K and H. So H is located at 3, 7. And so when it's transformed to H prime, in other words, rotated 90 degrees, these two values are going to flip sides. So you're going to have 7, 3, and the x-coordinate is going to become negative. And that's going to be the new coordinate for H prime. Now we can also do the same thing for, let's say, K. K is located originally at 8, 4, and when it's transformed to K prime, the two values are going to flip, right? So the y value is going to be in the x-coordinate spot, so it's going to be 4, 8, and this first coordinate is going to turn negative, right? So we basically have taken our xy's, we flipped them, and made the first one negative. And now that we know the location of those coordinates, we can go ahead and plot points for them. So this one's going to be at negative 7, 3, and K prime is going to be at negative 4, 8. And now that we have these points, we can kind of see where the fourth one is going to go, right? It should be right about there. And so now we can connect those points, and we have our shape rotated 90 degrees counterclockwise about the origin. Okay, so now number 4 asks us to rotate a different angle and wants us to rotate 180 degrees counterclockwise. So if we go back to our coordinate reference sheet, we can see here that a 180 degrees counterclockwise rotation is going to take our original xy coordinates and it's going to transform them such that it's negative x, negative y. Okay, so let's go ahead and use that. Our xy coordinates are going to be transformed such that we have negative x, negative y. Okay, so how's that going to look? Well, n, which is initially located at 2, 3, is going to be transformed such that it is now at negative 2. Well, hold on here. N is located at 2, negative 3. Excuse me. So now the new point is going to be located at negative 2. And then we have our negative y here. And you might be thinking, well, it's already negative. Well, that's saying to basically take our negative y and make it negative again. And a negative times a negative is a positive. And so basically we're just going to flip the sign and make it positive. Okay. So there's our first point. Let's continue. M is going to be located at 2, negative 8. So M prime, and I should be labeling these, is going to be located at negative 2, positive 8. And P is located at 4, negative 8. And so P prime is going to be the negative of those two values. And so we just flip the signs, which is going to be negative 4, positive 8. Okay, so now let's go ahead and plot those and see what this looks like. Negative 2, 3 is located here. Negative 2, 8 is located there. And negative 4, 8 is located here. Awesome. So let's go ahead and connect these points, see what we get. So now we've rotated triangle NMP 180 degrees counterclockwise about the origin. This is the coordinate notation for that transformation. This was the coordinate notation for a 90 degrees counterclockwise transformation. Okay, so now let's talk about reflections. So to reflect ABC over the y-axis, we just need to know that B is the same distance to that y-axis as B prime. Okay, and reflected is another word for flip. So our reflection should look like this triangle flipped over this y-axis. Okay, so let's go ahead and do this. B is 5 units away, and so B prime is going to be 5 units away in the opposite direction. Same thing with C, and same thing with A. And so now we just connect those points. And we reflected ABC over the y-axis, using the knowledge that 2 points that are reflections of each other are the same distance to the line of reflection, right? A is negative 9 units away, so A prime is 9 units away. Okay, now if we go back to our coordinate transformation sheet, we'll see that if we reflect over the y-axis, our y stays the same, but our x changes signs. And we can see that here, right? These are our y values, and so our y value stayed the same, stayed at 2, but our x-coordinate changed signs. It went from being a negative to a positive. And so to describe this transformation, we're going to write that our coordinates x, y were transformed such that our x-coordinates changed signs, but our y-coordinates stayed the same. And you can verify that for yourself. Okay, now here we want to reflect over the x-axis. And so we're going to flip this shape over the x-axis. And we're going to use that same knowledge that 2 points that are reflections of each other are the same distance to the line of reflection. So E is 4 units away, so E prime is going to be 4 units away. F is 4 units away, and so F prime is going to be 4 units away. G is 6 units away, so G prime is going to be 6 units away. Finally, D is 6 units away, and so D prime should be 6 units away. And we just connect those points. And you can do a better job than me. But it should look something like that when it's reflected over the x-axis. Now to describe this transformation, it's pretty much just going to be the opposite of what it was before. And you can see this on your coordinate transformation reference sheet, that our xy's are going to be transformed such that our x values have stayed the same, but our y values have changed signs. And just to confirm, we come over here and we see that same thing. Okay. So now I want to talk about how we can combine these translations, reflections, and rotations in this section here. So question 1 here wants us to translate ABCD 5 units to the right, then rotate 270 degrees counterclockwise about the origin. So let's go ahead and do the translation first. If we slide A to the right 5 units, is going to be located here. B will locate it here. D and C. Okay. And so now you can get each one of these coordinates here, A prime, B prime, C prime, D prime, and you can transform it, each one of them individually using the coordinate notation for a 270 degree counterclockwise rotation here. But I'm going to go ahead and show you a shortcut. So if we want to rotate 270 degrees, and that's a horrible way of writing that. So let me redo that. So we want to rotate 270 degrees in the counterclockwise direction. But 270 degrees in that direction is the same as a rotation of 90 degrees in the clockwise direction. So if we rotate this 90 degrees this way, we're going to get the same result as if we rotated it 270 degrees this way. And so the way we can make this much easier is by using the hook method. And so I'm going to use the hook method. So if I draw a hook to this point here, and I rotate this hook 90 degrees, this portion is going to be vertical. So we're going to go 2 units this way. And then this portion here will be on this side. So we're going to go 1 unit this way. And that's our new point right there. And so now we can do the hook method for all the other points and do this rotation relatively quickly. So here this long side of the hook would be 4 units, and this would be 1 unit. So we go 4 units, 1 unit. This hook is 2 units, and then 5 units, and so we would go 2 units, and then 5 units. This hook would be 4 units, and then 5 units, and so when that's rotated 90 degrees, it would be 4 units, and then 5 units. So now you can just connect that. And there we would be able to rotate this object without having to go through each coordinate, coordinate by coordinate. Of course, you could do it either ways. Okay, so now let's find the coordinate notation to describe these transformations. So we had our original coordinates x, y, and then we translated to the right 5 units. And so if we translate to the left or right, the x coordinates affected. So we're going to say x plus 5, y. Describes that translation. Now here comes the tricky part. Now we want to take these coordinates that we translated 5 units to the right, and we want to rotate them 270 degrees counterclockwise. Well, if we go to our reference sheet over here, we'll see that a 270 degree counterclockwise rotation about the origin transforms our original points x, y such that they are y negative x. And I have that listed out here so that we can readily see it. But now our coordinates are not x, y. Now they're x plus 5y. And so what you need to make sure is that you treat x plus 5 as your x coordinate in its entirety and y as your y coordinate. Okay, so when we look at this and we want to transform it in this way, obviously our y is going to go first, right? We take our y coordinate, which is y, and we place it first. But now our x coordinate, which we need to turn negative, is this entire expression here, x plus 5. And so that's going to be negative x plus 5. Okay? All right. And so now question 2 says to reflect triangle ABC over the x-axis, then translate the image 3 units up. So let's go ahead and do this one. So we want to reflect this over the x-axis. And so if you remember, C prime is going to be the same distance as C is from the x-axis. And so it should be located here, B should be located there, and A should be located right about here. Okay, so now let's go ahead and connect these points. Okay. And now after doing that reflection, we want to translate it 3 units up. So we're going to go ahead and translate this 3 units up. So this point is going to go 1, 2, 3 units. This point is going to go 1, 2, 3 units. This point is going to go 1, 2, 3 units. So if we connect those points, it should look like this. All right. And they want us to label this A double prime, B double prime, C double prime, but I'll leave that to you to do. Okay. So now to describe this transformation in coordinate notation, we're going to take it transformation by transformation. We're going to say that our original points were x, y. And when we reflected that over the x-axis, that became such that the x-coordinates stayed the same and our y-coordinates changed signs. And now we want to translate those coordinates up 3 units. And so we're going to add 3 units to our y-coordinate, which is now negative y, right? And so the total transformations is going to result in the coordinates changing into this, right? Negative y plus 3. And so if you took any one of these points, A, B, or C, and you got the coordinates for those points, and you plugged it into here, you would be able to get the new points, A double prime, B double prime, C double prime. Okay, I hope that was helpful, and if you have any questions, feel free to ask. That's all I got.